Boom, bang. The thunderstorm. You've got the thunder, you've got the lightning, and generally you have a power outage. And when that happens, the first thing we got to do is get the power back. So today we're going to talk about backup generation. Backup generators, we're going to talk about PDUs, UPSs, manual transfer switches, and all kinds of fun stuff related to power. There's a lot of things you really need to do before the power goes out, and by the looks of what's going on right now, I may have to worry about that in a little bit as well. I probably need to get inside. Yikes. Yeah, it's getting bad. We need to close this door. Wow. That's a pretty good storm going on out there. Lightning, thunder, all that stuff. All right. So let's talk about backup generators. What do we get? Oh, man. Hang on. Oh, lots of thunder. Okay, I think. Ow! Ah! Okay, hang on. Hold on, we gotta call somebody. All right. Yeah, hello. Is this Bob's Generators? Hey, oh man. Yeah, I imagine it is busy. Hey, obviously you know why I'm calling. Do you have any generators? You do? Okay, great. Well, how big? Well, I don't know. What do you suggest? Okay, well, what if they're all gone? Okay, well, just give me what you can. What? Well, I don't know the voltage. I'm not an electrician. I don't know. Single phase. Did you say 3-phase? I don't. Is that something you can figure out? I mean, walk me through it. What can I do? It's kind of hard to see right now. Ow! God. Delta connection or Y connection. Okay, I'll try to figure that out. Am I going to shock myself trying to figure this out? Well, yeah, the voltage, amperage, I don't really know. Just give me what you think, and I'll take as big as you can get. Yeah, well, yeah, I know you guys are busy, but I'll just take what you can do. So the generator showed up. Man, I can't see a thing out here. Come on, flashlight. There we go. Oh, wow. Okay. Well, he said that was the biggest they could get me. It's not very big, but he said it would do everything that we need. Okay. Did the guy leave any instructions on what to do with this, or did he just drop it off?
Yeah, he just dropped it off and told me to sign some papers, and he drove off.
Oh, great. Well, how do I connect it? Okay, well, I guess we need an extension cord. Okay. So now, I guess I'll connect DC 12 volt, 20 amp. I don't know what. Let's call this guy. Yeah, hi. You guys just dropped off a generator at my house, but the guy just dropped off and left. How do I, he didn't leave any instructions, so how do I connect it to the house? Well, yeah, I've got an extension cord. You mean I can use a regular extension? Oh, I have to have a special cord, but what am I running it into? I mean, there's a plug here on the wall that I can see. Well, it has to run into the circuit breaker panel. Okay, well, what cable do I use for that? Oh, okay, okay, hold on. So I have to connect this into the circuit breaker. How do I know what to do? I should have an electrician do that? Well, why didn't you tell me that in the first place? Okay, fine, all right, more money, I'm sure. Okay. Do you have some electricians, or do you have somebody you know? They're all busy. Of course. Okay, so I've got a generator here, but I've got no way to connect it into my house, and so what, am I just supposed to run extension cords off the generator and pull the wire into the living room? That's Not what I was hoping here. Great. Power. We put a lot of importance in this little thing we're looking at right here. And in a disaster, it leads to everything. We can't power up communications. We can't turn the lights on. We can't get the air conditioning going. We can't get the heater on. We can't get the security cameras to roll, the video camera footage. It's critical. I have a phrase that says, a picture says 1,000 words. And I think this picture right here sums up the situation that I was in last night and what many others fall into. Unfortunately, when the disaster happens, it's the people that find themselves in this predicament, and now they're trying to solve it, and they know that the next few minutes, hours, days are not going to be good. To start our session today, I want to use this picture. This picture sums up a lot, and many of you might automatically know, oh, I know what that is, and that's great. We will talk about that piece of it, but I believe there is much more to this picture that can portray and has a lot of lessons learned just in this picture. So we're going to talk today about the different pieces of the puzzle to start to decipher this picture and understand why it means so much to me and why it's a great picture of what disaster response should be. Power's on. I hope you enjoyed that little scenario from last night. So we're going to put the pieces of the puzzle together. And I want to explain that as we talk today, we're going to talk about different pieces, but those pieces, they are applicable to the scenario of restoring power to a house or restoring power to a, regardless if we're talking about a power system at your house or a power system at a big building like this behind me, it's the same. So let's learn what those are. Okay, before we go any further, stop. Power is confusing and it's dangerous. I know all of you have a box like this at your house, all kinds of power adapters. What do we got here? 120 volt AC, 60 hertz, 15 watts. This one says DC 4.8 volt. This one says 120 volt. This one said 100 to 120 volt. It's confusing and it can be very, very dangerous. And anytime you're working with any electricity, get a licensed electrician to help you walk through this stuff. You're going to find that this gets complicated really quick. And you've got to work with an electrician who went to school and knows all these different parts and pieces so that you don't hurt yourself and hurt yourself bad. All right, let's continue on with pieces of the puzzle. Generator, power source of some type. PDU, power distribution. We're going to go into each one of these individually. And the load. And the load is probably the most important part of this whole puzzle. But let's start first with the generator. They can come in all different shapes and sizes. They could be diesel generators, they can be natural gas generators. They rate them in kW size. Sometimes you'll see that as kVA size. This is a 3 kW generator. You can go up to 100, 150, 300, 1 megawatt, 2 megawatt. Big giant generators on big flatbed trucks. They might have single phase output. They might have 3-phase output. You might need a delta connection. You might need a Y connection. You have 120 volt output circuits. You have 240 volt output circuits. You see where I said it gets confusing? Understanding what type of generator you need is important in this puzzle. And you don't know the answers to that until you actually do the proactive work that we're going to talk about to figure what this needs to be. It's critical, and if you don't get it right, just like we learned last night, how are you going to connect it up? What are you going to do? You have power coming in from the utility or let's say from a generator. And now you've got to distribute that power throughout your house or building facility. So you have something like this, You could call this a power distribution unit or a PDU. Now yes, a PDU you typically think of as much larger, but this is the same concept. You're taking inbound power and you're breaking it up into individual circuits so that different appliances can plug into it. Now there's probably a fuse on the system somewhere so that if any one of these pulls too much power, then the fuse will pop and it will turn off so we don't start a fire for safety reasons. Take this one step up and you have one of these on your house. It's a circuit breaker panel. Same concept. You're taking in power from the utility, you're breaking it up into the different receptacles. You have a circuit breaker for each of those that is like a fuse, so that if power pulls too much on one circuit, it will trip off so there isn't a fire. Take that one step further and now you have what we might traditionally call a PDU. That's a large power distribution unit. Same concept though, you're taking inbound power, you're breaking it up into different circuits and distributing that across multiple floors or locations within a facility. So we move from the power distribution unit, the power strip, that's got our inbound stuff coming in. So I would put that into the source. In this case, we'll use utility power. A little bit too loud to run the generator in here. And now I'm going to distribute it to my devices, or what I'm going to call collectively the load, the power load. All right, we have a light, I've got a heater here, and I've also got a fan. So that power load is what's being pulled through the circuit right now. That fan felt good, but I got to turn it off, too much noise. The load is almost the most critical piece in the whole puzzle, because determining the load helps to identify what size this needs to be and what size the generator needs to be. You're going to have some systems like environmental systems that pull a lot of power. This heater pulls a lot of power. The fan might, an air conditioning system definitely would. Lights maybe not so much. But collectively in a large facility that can all add up. And as you start to think through that, again, before the disaster, you start to understand what's important and what's not. Sound familiar? Don't try to recover it all. It's too expensive, it takes too long. So as you walk through things, what about, I always see people put up the Christmas lights, right? I don't think in a disaster the decorative Christmas lights on the front reception desk are critical. That's a good example. So we wouldn't want that, right? We would unplug that. You walk through systematically through all your systems and figure out what are the critical things you need. Why? Because it's going to save you time and money down the road. Next piece of the puzzle, the UPS, otherwise known as a battery. Uninterruptible power supply. That's just a fancy word that in larger facilities you'll find a UPS, which is a large bank of batteries. Now they make some smaller ones as well that are just one battery, and then big cases that have multiple batteries. A UPS is there for the transition when the power drops. So we have our load, all of that equipment is on, and we're going to transition from utility power, which dropped, and if this was connected to the UPS, then that load would stay on until an automatic transfer switch would do what I'm doing here manually, which would tell the generator to turn on and to switch the circuits to provide power from the generator. All the while, this battery backup is supplying power to the load. Now, most of you don't need to worry about this because it really only comes into play for data center situations. But this is designed to maintain critical circuits throughout. And how big the battery is determines how long those things are going to stay up. Again, the key piece to all this is the load. If I tried to run all of this equipment, this fan, and especially this heater and this light on this battery, I may only get 5 minutes, if that. But if I decided to unplug some things, let's say let's unplug the heater and unplug the fan, then that light would stay on and this battery backup would last a lot longer. Remember, it comes back to the load that you've got on it. So again, an automatic transfer switch will detect that utility power just dropped. It's going to sustain power for a limited amount of time until we can reestablish power from another source, likely a generator. And that's where a UPS plays in to the puzzle. Now, we're not going to talk about this much more because for the rest of this activity we don't need to, but I just wanted to make sure I touched on that so you understand what that is and where that plays in. Ultimate goal here is to create something called a manual transfer switch. Some people call it a quick connect. Remember last night when the generator finally showed up, I didn't know where to plug it in, how to physically plug in my stuff. And going through setting up a manual transfer switch is a proactive exercise that you can do that starts to solve all these pieces. Of course, you could call a generator company and they can drop off a generator, and you can do what I'm doing here, which is plug an extension cord into the port and run it into the house and put a surge protector on it, and maybe that would work, but you got lots of cables going in lots of different doors. There was a major water main break and the crew was trying to fix it, and the water was running down into a shipping dock that you see here. You can actually see the water line on that door there of how high the water got up. Well, the water got inside of that facility into the basement area, and inside of that was their generator. And the automatic transfer switch worked as it was supposed to. Power went down, it said, oh, hey generator, you need to kick on and do your job. The generator turned on, it sucked water into the generator, and here you see the nice after effects of that, and the fire department showing up to deal with the issue. After that, they had generators to pull up, and you can see the cables that had to go in through a smashed out window, and those cables were running into various parts of the building to identify the circuits that were key. Can you imagine how long that took to figure out what's important? How do we do this? So even though you have a dedicated generator, and we're going to talk about that in a bit, you still might want to look at going through this exercise because it's going to reveal things that are good for you to think through in a disaster. I'm hoping these crazy things I'm doing are making some sense to you, even if you're not an electrician at all. But a manual transfer switch. Okay, how do we determine that? You got to figure this part out. You got to figure this part out. Well, it all comes from the load. So, first thing you need to do, what's important? What's not? What can you support? Now, many people may go, well, wait a minute. How do I size this? Or how do I size that? A couple ideas. One, you can go look at the panel itself, and the panel will tell you how much that panel supports. Now be careful of that, because that's going to tell you how much the panel can take max. What's the max load? But that's not your actual load. And you can determine that possibly by going to your utility bills. Look at them. They'll usually tell you peak usage. Again, like I said earlier, you work with your electrician to understand all those numbers and what they mean. But that's going to give you a good idea of your load. And then with a little more homework, you can identify possibly the load with those critical circuits. That is going to tell you how big of a panel or what circuit breakers to redirect, how to design that. And that, in turn, will tell you what size generator you need, or what type, and what connections. And then you can build all that out into a manual transfer switch like you see here. And when the power drops, you then call for a generator. The generator shows up, you take the output from the generator, you click it in, you know the circuits you need to be up and running will be powered up, it's designed, and you're up and running. That's the concept, that's the idea. Yes, it takes some work. And yes, it's probably a pain in the butt to go through all those motions to figure that out. But ultimately, it is going to save you money at the time of the incident, because that's a whole lot cheaper than a 1 megawatt. So some people may say, Steve, I'm trying to figure all that out. The load always changes, my building changes. Why don't we just go with a dedicated generator? Okay. Like this person here, they went with a dedicated generator. And if you go back and watch session number 2, that's a great place to understand the risk appetite. Along with this big generator comes a big giant fuel tank. And that fuel will get filled up all the way, maybe 1,000 gallons, 1,500 gallons, whatever it is. And it sits there. And backup generators, especially dedicated, you hope you never need them, right? So that fuel will sit there, and it'll sit there. Now occasionally, they'll do a preventive maintenance check. They'll turn it on, they'll see if it turns, cranks on, they'll leave it running for 10, 15 minutes maybe, and then they turn it off. That's dangerous, and here's why. Because that fuel tank will have what they call particulates. Sometimes they switch between types of fuel, like you have summer blend and winter blend. And there's different things that'll settle into the tank. And if you don't use that fuel could be sitting there for 2-3 years. So now you have to worry about fuel conditioner. They suddenly now need the generator. It's a disaster. They turn it on, it starts running for 24, 48 hours. All those particulates come up into the system, they clog the fuel filter, and now your dedicated generator that you spend all that money on dies. And because you didn't go through the motions of identifying and creating a manual transfer switch, now we can't even pull up quickly with a big backup generator to solve the problem. And that's even worse, because now everybody wonders why they don't have power, and you just spent a ton of money for a dedicated generator. Pros and cons. If you're gonna do a dedicated generator, remember, just like in session 2, there's the capital cost, but it's the preventive maintenance costs. And what I suggest to people is when you do a PM check, don't just turn it on to see if the engine cranks. By turning it on and running it for a few hours, you're accomplishing 2 things. One, you're getting that fuel in there and using it up, because you don't want old fuel in that tank that's 5 years old. And secondly, pieces of equipment like this, like any vehicle or hardware, they need to move. Sitting dormant, not doing anything, they're not designed to do that. So gaskets get old, seals get dry and cracked. So move it up, and even better, you should go in there and flip the Frankenstein switch. You know what I mean? That's that utility room, and where utility power is coming in from the city. Go in there and once a quarter, and again with an electrician, flip that Frankenstein switch. Why? Because that's going to test your automatic transfer switch. Is that going to tell the generator to turn on properly? Then are you sure that your other circuits are going to come on? It tests the complete system. Hopefully you understand each of those pieces and how they all fit together. And now that picture I talked about. That picture came from here. And it's a picture and something you'll probably see in a lot of hospitals. It's the red and the white plug. And a lot of you, I'm pretty sure, got right. Yeah, the red plug's on a generator backup, and the white plug is just a regular plug on utility. You're correct. And that's a great way to help people understand which circuit is on backup generator power and which one is on utility power and could drop. But here's the pieces you need to look a little forward to now that you know all those pieces to the puzzle. Number 1, how much power do you think that entire facility needs? That's a big generator to run that whole thing. Well, guess what? That's too big, and that's too expensive, and it doesn't make sense to do that. So they went through the process of identifying the critical circuits, the people that are on ventilators, the people that have life-saving electricity needs, and they identified that. So that's one big piece of why that picture means a lot to me. The second piece is that it's great training, it's good identification for a disaster preparedness plan. If it's a critical piece of equipment, you plug it into the red plug. If it's not as critical, you plug it into the white plug. Simple. Keep it simple, stupid. That's what we always want to try to stick to when we talk about disaster recovery. So pictures say 1,000 words. And hopefully now, when you look at this picture, you got a lot more words and understanding of why it's a powerful picture in many ways. It's saving money, it's being smart, and it's being prepared. When the power goes out, I hope this video doesn't haunt you. Take the time, be proactive, figure out the electrical circuits before power goes out, and you're going to be a much happier person. That's another session. Thanks, until next time. Hindsight 2020.